4. Picking up 5 cards out of a deck, find results of getting 2 jacks and 3 kings. Probability. Random experiment. Random experiment is experiment that cannot be forecasted before completing the experiment, although we already know all available outcomes of the experiment. For example, 1. Throw a coin 1 time once can be head or tail. 2. Result of throwing a dice once can be 1, 2, 3, 4, 5, or 6. 3. Picking up 1 card from a deck. Sample space. Sample space is set of all available outcomes from random experiment represented by S and the cardinality of S represented by NS.
Example: find sample spaces of the following random experiments. 1. Tossing a coin once. Let H be result of head and T be result of tail, so S equals H, T, and Z equals 2, 2. Tossing 2 dices at once. So S equals 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 6, 6, 1, 6, 2, 6, 3, 6, 6, and Z equals 36. Example: a box contains each of white, orange, and red table tennis balls with the same size. Write sample spaces of the following random. 1. Picking up 1 table tennis balls. 2. Picking up 2 table tennis balls. 3. Picking up 2 table tennis balls one after another and no returning of already picked up back to the box. Solution: let W represents white table tennis balls, O represents orange table tennis balls, R represents red table tennis balls. 1. Picking up 1 table tennis balls, S equals W, O, R. 2. Picking up 2 table tennis balls at once, without regarding of order, S equals W, O, W, R, O, R.
Events. Events are sets of interested results from random experiments. Events are subsets of sample spaces usually represented by capital letters, for example, A, B, C, D, E. Union of event. E1 union E2 means event consists of elements in either E1 or E2 or both E1 and E2. Intersection of event. E1 intersection E2 means event consists of elements in both E1 and E2. If E1 intersection E2 equals empty set, we call E1 and E2 independent events. Difference of event. E1 minus E2 means event consists of elements only in E1 but not in E2. Complement of event. E prime means event consists of event in sample space but not in E. Vocabulary. Committee, forecast, toss, dice, examinee. 3. Given S equals O, 1, 2, 3 through 9. Let E1 be event of event number. E2 be event of prime number. Right set of E1, E2, E1 union, E2, E1 intersection, E2, E1 prime, and E2 prime. Probability of event. Probability of event is a chance which event can occur, usually written in fraction or decimal. Let S be sample space, and S be cardinality of sample space. E is event, and E is cardinality of event. PE is probability of event, E. So, PE equals NE over NS.
Example: tossing 2 coins for 1 time. Find probabilities of 1, tail on both coins, 2, head on at least 1 coin. Solution: let H be coin come up with head and T be coin come up with tail. S equals HH, height, TH, TT, and Z equals 4, 1. Let E1 be event with tail on both coins. E1 equals TT, and E1 equals 1. PE1 equals, so probability of tail on both coins equals to or 0.252. Let E2 be event with head on at least one coin. E2 equals HH, height, TH, and E2 equals 3. PE2 equals so probability of head on at least one coin equals to or 0.75. Example: randomly pick one card from a deck of 52 cards. Find probabilities of the following events. 1. Picking red card. 2. Picking diamond card. Solution: let S be a deck of 52 cards, and Z equals 52.
Properties of probability. Important properties of probability are as follows. Let E be any event and S be sample space. Properties related to probability of E are: 1. O less than or equals to P, E less than or equals to 1. 2. If E equals empty set, then P, E equals 0. Therefore, P empty set equals 0. 3. If E equals S, then PS equals 1. Therefore, PE equals 1. Vocabulary: probability, permutation, experiment, random, particular, contain. Some important rules of probability. First rule: if E1 and E2 are any events and are subsets of sample space, then P E1 union E2 equals P E1 plus P E2 minus P E1 intersect E2. Second rule: if E1 and E2 are any events which do not coexist with sample space, then P E1 union E2 equals P E1 plus P E2. Third rule: if E is any event and is subset of sample space, then PE prime equals 1 minus PE.
Find probability of picking odd number or number divisible by 3. Let S be sample space of integer ranged from 0 to 19. E1 be event of receiving odd number. E2 be event of receiving number divisible by 3.